Alex and I want to focus on two very specific perspectives. And at the question and answer period, maybe we can expand those perspectives. But we think that these two perspectives are particularly suited to the Vision 2020. And so the two perspectives are the relentless nature of physics and the relentless physics of nature. You know, an awful lot of my time is taking a look at the science of the building enclosure. And, you know, older walls, the physics was pretty simple, straightforward, simple, robust products. This is my house built in 1911, and this is part of the retrofit we were doing to expand the kitchen. But how many layers does that wall have over on the right-hand side? 3. Concrete block, wood lathing, and plaster. It's pretty easy to get the physics of that right. And there's only really 3 things that we're asking of that wall: structure, finish, and management of bulk water. What about even just a typical wall today? So let's just take a typical residential wall. How many layers or compositions does it have? And again, this is my house that I'm using an example. Start off with the exterior finish. In this case, it's paint. We add the cladding. We're going to put up the weather-resistant barrier. And notice, I'm not counting the furring strips in the airspace, because that's not typical. We're at 3. We go to the structure, adding sheathing and framing. I'm up to 5. We go to the inside of the building. We add insulation, the vapor retarder, and the gypsum board. 6, 7, and 8. And then finally, we add the primer and the interior finish. 10 layers in a typical wall. And when I do this exercise with builders, we spend about 20 minutes doing it. And we generally get ranges from 4 to 12, right? And there's a lot of surprise with this. But here's the interesting thing about this. Each one of these layers, how many products can we use within each layer? A dozen, 2 dozen, 3 dozen? When I teach building science to builders and architects, they look at me with that desperate look on their face like, please, we need help. And the thing is, the assemblies and the materials don't need to understand the physics. We do, right? And that's the real key to the relentless nature of physics.
All right, let's back up a little bit and talk about some of the drivers that affect the green building community and the industry. And I'm going to just touch on a few of these. There are many drivers out there. One that provides, I think, a very good example of how manufacturers responded was the ozone hole. This was theorized back in the 70s. It was first identified and measured in 1985. In 1979, as shown in that upper graph on the left, there was 0 ozone hole. By 1990, it had grown dramatically. You know, unfortunately, it stayed fairly steady since then, but a big problem. And you know, it creates this large hole where there's inadequate ozone to protect us from ultraviolet light. Big problem. The government recognized it, environmental communities recognized it, and manufacturers accepted it and did what was needed to make changes. Manufacturers responded beautifully. Refrigerants and blowing agents changed very quickly. Manufacturers stepped up to the plate. By 1995, CFCs, or chlorofluorocarbons, were eliminated, end of 95. By 2010, nearly all of the second generation blowing agents, the HCFC, hydrochlorofluorocarbons, were eliminated. So that got us down to 0 ozone depletion. You know, huge credit is deserved by the industry for that. Another big driver, one that Ed's talked about and others this morning and today, climate change. You know, huge problem. We've all seen graphs like this, the one on the left showing temperatures and how those have changed given the long-term mean. On the right, different scenarios of what happens with a low emission scenario and a high emission scenario in terms of numbers of days per year above 100 degrees. In red is the dark rate 120 days. So you can see in the high emission scenario, you know, huge problems with heat buildup in particularly the west and south. Other graphs, we've all seen stuff like this. It's hard to escape the reality of it, not that that isn't done, but it's a big challenge faced by industry, and it's a hard one. It's harder than ozone depletion. Environmental building news, I think, generated more controversy than about any other article we've done in identifying the issue of global warming potential of insulation materials. This is the idea that the blowing agents used in a few types of common insulation materials have a very high global warming potential. That means that all insulation is great in terms of saving energy, but we've always in the past had this idea that more is better. In most cases, it's always good to if you're at R20 to go to R30, if you're at R30 to go to R40. But what we showed with this study, and it was based on some scientific research that had been done, the payback through energy savings, when we save energy, we reduce fossil fuel consumption, that it reduces carbon emissions. The savings, there's a significant payback issue that can, in some cases, span 100 years or even longer to pay back that embodied global warming potential that's going to escape over time, over the life of those insulation materials. Even when we do the right thing, we think we're creating a state-of-the-art green home. This is a passive house using the German standard under construction in New York State with a foot of extruded polystyrene under the slab. That's going to take well over 100 years, maybe several hundred years, to pay back the embodied global warming potential of that blowing agent. A big issue. Now, manufacturers are responding, and they're really stepping up to the plate. Companies like DuPont and Honeywell now have fourth-generation blowing agents, often HFOs, hydrofluoroolefins, that get down to very close to zero global warming potential, in addition to having that zero ozone depletion potential. Third driver I'll talk about just briefly is water. And Marianne talked about water a lot. I think this is a huge issue, likely to be even a more significant issue than energy over the coming decades. We're beginning to see this in the last couple of years, major droughts that have been experienced in parts of the country. We've seen photos like this. Marianne showed some others. Lake Mead on the left is at about half of its capacity. In the east, we tend not to think about drought as much, but actually the challenges are often greater. Our reservoirs tend to be shallower, they get depleted more quickly, and we don't really know what to do about it. When Atlanta came within 30 days of straight out running out of water in 2007, there wasn't a plan in place of what to do about it. In the West, at least, they know about water issues and have an idea. The governor had the state pray for rain, and it worked. Great resource, if people aren't familiar with this, the U.S. Drought Monitor, maintained by the University of Nebraska in Lincoln. You can download weekly maps showing the extent of the current drought conditions. And manufacturers have really stepped up to the plate. Shown here are just a tiny sampling of the thousands of products that have come out to really push the envelope with water efficiency. On the left is a Delta H2O Kinetics shower head where they re-engineered the shower head to create large droplets that retain heat and also forceful delivery. So you get a very satisfactory shower at a 1.5 gallons per minute instead of the 2.5 legal limit, or the 5 or 10 or 13 as is sometimes found still today. I've had one of these for the last 5 years and love it at our home. On the right is the Niagara Stealth Toilet that Marianne mentioned, and this is an example of some real brilliant innovation that the developer of this went through to create in this trapway a bubble when it gets flushed, an air bubble, and then that results in suction, or a vacuum, a passive vacuum that sucks water out of the bowl to enhance the flow. So the performance here meets most common 1.6 or even larger flow toilets today using just 0.8 gallons per flush. Real dramatic improvement. Manufacturers have responded another way, not only in making water-efficient products, but in re-engineering their processes to use less water. And this applies to all types of manufacturers, from electronics to water efficient fixtures. This happens to be a Toto factory in Atlanta, where they're recovering water from the clay that gets baked out of this and using that to reduce their domestic water consumption by 700,000 gallons per month.
So Alex has laid out a case for the relentless physics of nature. I'm going to go back a little bit to also, we talk about innovation, we're talking about change. And one of the things that's really different nowadays is the pace of change. Let's take something as simple as the weather-resistant barrier. Up until 1980, this is what you did, right? Building paper. It's kind of like the Model T Ford. You can have building paper in any color you want as long as it's black, right? And then not long after that, we got hit in the industry with all these great new products, right? All different types of house wraps, all different colors. It was as if you could walk down the street in a new development and see what the color of the gift wrapping was going to be this week. And I'm making a little bit light about that, but that's really challenging to the manufacturers and also to the users because these all have different performance properties. So it's challenging. When we combine the relentless nature of physics, complex building solutions, and rapid change in the way that we do things and what we build with, sometimes the consequences are not what we intend. And remember back to that 3-layer wall that was doing just 3 things, managing bulk water? We're asking our assemblies to do way more than 3 functions. In fact, this builder, very reputable builder in southern Vermont, this is a 10-year-old vacation home that had a small problem that they noticed on the inside. And it turns out that they were managing energy pretty well, but not managing moisture. And the physics is relentless. You can't manage one, you have to manage both. If you manage one more intensely, you must manage the other more intensely. So this is real liability. It's not liability for one part of the industry, it's liability for all. So how in the world do you take that type of challenging environment and the risk involved and change it into a business opportunity? Well, we think one way that it can be done is by taking a systems approach to product development, and that means product integration. Now, I'm going to give an example here, sort of one of the really extreme examples, which is Tremco manufactures commercial building sealants. They have a new package called the Engineered Transition Assembly, where every single component is part of their package. And their technical staff work with the architect, the construction supervisor, and the specifier to go over every single detail for that project by project to make sure that the air barrier and the water barrier are continuous. And here's the kind of coup de grace, which is they guarantee the performance of the water and air barrier if you use this system and if you go through their process of detailed plan review. That's a bold new approach to integrating products. But what a business opportunity, right? Rather than fighting how difficult it is to get the physics right, say, I'm going to take that on. I'm going to try to capture all that product opportunity by weaving them together. Now, to do that, something as risky as a guarantee, you better get it right. So Tremco has built a new research facility in Cleveland, Ohio, called the Sustainable Building Solutions Facility. And they partnered on this in part with the Air Barrier Association of America and DOA's Oak Ridge National Lab, right, to sort of build even greater momentum for what they're doing. And this facility is the first to do whole wall, full water and air barrier continuity testing that's available. Really a bold new approach. I taught high school chemistry and physics and a long time ago. And you were all familiar with the 3 top bubbles, right? But come on, is nothing sacred? What about this 4th one? Oh yeah, so the relentless nature of physics means that it changes over time. So in addition to all the other changes, we have to have changing physics. Well, this last type of transition for a state of matter is specifically for water and porous building materials. And it was theorized and developed over the last 20 years because building scientists need to explain the way that moisture was moving through materials. Now, here's the thing. It's not the physics that have changed, it's our understanding of the physics. So when we talk about changes in the industry, new understanding brings new tools. I mean, who would have thought that in 2012, things like moisture meters and infrared cameras would be in the toolboxes of all leading architects and builders? They have to be. Why? Because we're building much more complex assemblies. We're asking them to do a lot more. Now, one particular tool that we've found really, truly amazing is WUFI is a software modeling program that takes a look at the water and energy management for an entire building assembly. Okay? Remember those 10 layers and those 4 states of matter? WUFI is a program that can analyze every single individual layer of the assembly, as well as the assembly as a whole, in terms of all the heat and all the moisture flows in the assembly. Looks like a wicked complicated tool, but we need that to understand the physics if we're going to build these really complex assemblies. What in the world? How does that represent a business opportunity for product manufacturers? Well, it turns out that when you go into WUFI, there's a database of materials that you pull to build your walls or your roofs or your foundations, right? And they're all generic. You go in and you pull cellulose insulation. You go in and you pull EPS insulation, right? They're generic. And so just recently, the Braunhofer Institute for Physics in Germany and Oak Ridge National Lab said, you know what? We're going to open up the database. If you're a manufacturer and you provide us with all the hydrothermal properties we need, third-party validated, we will put your product in the database. Now, is that a business opportunity? Well, you bet it is, because all the leading builders that have the same Vision 2020 that you have, they're going to be looking at your building products. And if I have a choice between pulling, fiberglass insulation and Knauf insulation, I'm going to pull the one where I have specific properties. So, new tools, new challenges, new opportunities.
Okay, so I'm going to close this afternoon in transitioning from the relentless nature of physics to the relentless physics of nature. And shown here is a photo taken just a year ago in Vermont, where we're based. This is up near Killington, where Tropical Storm Irene came along and did to Vermont what other storms have done to many other parts of the country, but it brought it closer to home for us. There are plenty of other examples around the country where we've been seeing the impacts of more intense storms, wildfires, extended droughts, these kinds of conditions, some of which are almost certainly related to climate change. And what this calls for is a new focus on resilience. And I believe that over the coming decade, by 2020, there's going to be a very significant focus within the manufacturing sector on products that help us achieve resilience in our buildings. We're all aware of products like this. I mean, Simpson Strong Tie's been the leader for decades in hurricane tie-down strapping, other products to create stronger buildings that will resist storm events. Less well known are things like flood barriers. This is another photo. This is downtown Brattleboro a year ago. And behind me, if I'm looking at where I took this photo, and to the right, there's a building, the New England Youth Theater, a theater for kids. And they had recently rebuilt this building really from scratch and did a great job with it. And in engineering it, even though the building was a foot above the 100-year flood level, they put in these flood barriers. And the last person that left that Sunday morning deployed those 18-inch flood barriers. The water came up to within 1.5 inches of the top of those, saving the building. There was very minor damage, a little bit of seepage, but a great example of a great product in that's very cost-effective, inexpensive, and easy to value engineer out of a project, but important to keep in. We looked not only at making buildings more resilient to the exact storm, the event, whatever it is, a storm or a flood, but also what happens in the aftermath. And power outages are going to become increasingly common for many reasons, even drought. A lot of people don't realize that 89% of our US power production is with thermoelectric power plants that require a lot of cooling energy, a lot of cooling water to condense that steam back into water. In an extended drought, we start shutting down power plants. And I don't know what's going to happen if we go a couple of years without snowpack in the Rockies and the Colorado River, instead of drying out, Southern California dries out not long after leaving Colorado. It's going to be a huge impact. And as a result, we need to be creating buildings that maintain livable conditions, without power. And that's the underlying premise of resilience. And there's a lot that we can do there. It also applies to fire. Clearly some materials, like the autoclaved aerated concrete shown here, will do a lot better than others in a fire. But there are also simple products like soffit vents that exclude embers, which is the most common way homes burn down in the Southern California chaparral area, embers getting up into the attic. So a lot of things we can do. Our company, Building Green, has recently spun off a nonprofit, the Resilient Design Institute, to really push a lot of these ideas and create a different venue, a nonprofit organization that has different revenue streams available to it. Also opportunities for fundraising and sponsorship of the website. It'll be a free website and various services. So with that, just to reiterate, there are a lot of drivers of green building, of innovation in the building industry, and there are opportunities with every one of those drivers. So there's a lot of challenges for sure, but a huge number of opportunities as well. So thank you.